Let's set up a basic HoloLens 2 project in Unreal Engine 4. This is Unreal Engine 4.26.1. We start by creating a games project and choosing the blank template, as nothing here has any value to us on the HoloLens. Now, some of these decisions will actually matter. In general, you can use blueprints in C++ in any Unreal project, but in this case it's better for us if we start with C++ because we want to be able to compile the mixed reality toolkit from Microsoft. Next, we'll change the quality to scalable to fit the mobile device, make sure ray tracing is disabled, make sure we're choosing mobile or tablet, and we don't want any starter content. Place this project anywhere that you'd like. I'm going to call this HoloLens Setup. And we can create the project. When you start a new project in Unreal, it will always start with this sample map, which includes a few things like fog, lighting, and a skybox. We'll be creating our own map, as you usually should anyway, but we won't be using most of these objects in our scene once we get going on the HoloLens. We don't want to use any skybox because we're superimposing everything on the real world, and we're also not going to use much sophisticated lighting because the HoloLens devices are all fill rate limited. Let's start with just creating some folders to hold our maps and objects. So I'm just going to create a folder called Maps, maybe a folder called Blueprints, maybe a folder called Materials, etc. So everything that's within the content folder will be available here in Unreal Editor. So the first thing I'm going to do is just create a new level, or new map, empty level. And I always like to save everything once I started it because I don't want to lose it later. So we will save this as main. I like to call my main entry points main, so it's very obvious what the intention is. Let's prepare this level for mixed reality. The first thing we'll need to do is add an AR session configuration object. So I'm going to also create a new folder for data. And within that folder, I will go into the miscellaneous tools and pick data asset and look for AR session config. I'll just call it AR session config as well. If we double click into it, we can see that it offers us some general augmented reality options. So if we open up the world mapping, we can see options for generating mesh data from track geometry. I'm going to say yes. And we can also optionally generate the collision for mesh data, nav meshes, and also render things in wireframe. For now, I'm just going to check the generate mesh data and the track scene objects. So that will allow the HoloLens 2 to track the actual geometry of the real world, as well as things like your hands moving around. And I'm going to click Save, so now that this is saved. And I'll just close this editor. To make use of this AR session config, we can go into the level blueprint and add some code to the onBeginPlay and onEndPlay events. So for the onBeginPlay, we'll want to start AR session, and we can pick that AR session config data object that we've created. The next step would be, once the level shuts down, we would want to shut down the AR session as well. So let's add an event handler for endPlay. And this will be stop AR session. That's all we have to add to the level blueprint. The next step would be to add an actual pawn to represent the person wearing the HoloLens. So I'm going to go into Blueprints and add a new Blueprint class, not based on pawn specifically, but based on the default Pawn class. And I'm going to call it MR Pawn for Mixed Reality Pawn. And this is based on the Microsoft examples. So I just like to keep it consistent so anyone who's looking at this will immediately know what this means. It's not Mr. Pawn, it's Mixed Reality Pawn. Let's double click on that blueprint to open up the editor, and we see that it has a few components. It has a collision component, a mesh component, and a movement component. We're not overly concerned with this mesh component here, but they do have collision applied to them. So the first thing we'll want to do is disable that collision. So we see that if we click on the collision component, the collision category has a preset of pawn. We'll just set it to no collision. And likewise for the mesh component. So we want that to be no collision. The next thing we'll want to do is make sure that collision component is highlighted as it's the root component of the pawn, and add a camera. We don't have to do anything special here. Unreal will handle any sort of stereoscopic or any other appropriate techniques that are related to the rendering. So really, this pawn is ready to be used. The next step would be to define a game mode, which would use this as its default pawn. So create a new blueprint class and look for game mode. And I'm just going to use this Hololens to set up game mode base, since that's specific to our project. And I'm just going to call this Hololens to game mode. We can double click, and we have a few options here that might be relevant in other projects, but for now all we care about is this default pawn class. And I'm going to pick our MR pawn here, compile and save. And that's done. Now all we need to do is make sure Unreal respects our intended default game mode and level. So going into project settings, we can look for maps and modes, make sure we're picking our Hololens 2 game mode, picking our main level as the entry point for the startup on editor and the game, and that will essentially give us what we need to get a basic holographic experience. There are a few steps that require restart of the editor, and I would like to just do all those steps at once so we don't have to keep restarting. For one, we want to make sure that we are enabling the proper plugins. Let's go into the plugins and look for the Hololens plugin. Okay, we want to support packaging for the Hololens device, and we want to support Windows Mixed Reality. Okay, these are what we'll generally need to make the most of our device and prepare packaging later. Once we've enabled those plugins, a few other settings will appear in our project settings as well. Let us adjust some settings to improve the performance on the device. If we go to rendering settings, the first thing we see is the mobile category. We can reduce the number of cascaded shadow map cascades to 1. And immediately we see that a restart is required to apply new settings. So let us make sure we have all our settings in so we don't have to keep restarting. And honestly, this might also be moot as we might not be using shadow maps in general, but it's better to set this to 1 than 2. The next thing to attack would be the occlusion culling. Now, this almost seems unintuitive. You see that this would tell Unreal not to draw things that it can't see. But in a mixed reality scenario, you will see everything in the scene. Technically, it's overlaid on the real world, so everything should be a candidate for rendering, and this just causes unnecessary cost. So let's disable that. If we keep going down, we see that we can opt for forward shading. And the difference there is essentially we're saving a little bandwidth in the pixel shader, and the pixel shader is where we're going to hit most of our costs because we're fill rate limited. So let us choose forward shading. And we can keep going down and down until we get to the VR section here. We want to enable instanced stereo, turn off mobile HDR, and turn on mobile multi-view. So let's just hover over these tooltips. Single pass stereoscopic rendering on mobile platforms. We want any rendering gain we can get, and anything that we can do in a single pass is going to be better than doing it in 2 passes. So those are the main settings that I like to have on every single project that I do on the HoloLens. This is also a good time to install the Mixed Reality Toolkit, which is a plugin for Unreal that offers some basic HoloLens interactions out of the box so you can more quickly prototype and build your applications. You can find the plugin release as a zip file on the GitHub's release pages, and you would want this zip file here. As of writing, it is now at 0.11.0 as of December 17, 2020. This is the most recent version, and once you've downloaded this zip file, you'll want to extract it into the plugins folder of your project. So this is going to be the folder that actually contains your U project file. And you might not have a plugins folder, but it's fine to just create one. So we would create a folder and then extract that entire UX tools here, and you can see it's about 1.41 gigabytes. At this point, I've restarted Unreal to apply all my plugin settings, and it tells me project file is out of date. Would you like to update it? That's fine to do. I'll just click update here. Now, if I go into settings, project settings, I have a few more options that I'll want to address. So immediately, I should pick Start in VR. And this is something that matters when you start to deploy to the HoloLens. So otherwise it will run as a 2D application, as if it were in a flat plane. So you want to make sure that the Start in VR actually is checked. Next thing you'll need is some kind of project name if you're deploying to the HoloLens, as in like packaging it up and deploying it. I'm going to call this HoloLens 2 Setup, and you'll want a company name of some kind. I'll just use my name, Jason Aofi, and you'll want the distinguished name. And there are rules to this as far as company name and location, and it's required to have a real company distinguished name to deploy to the HoloLens as a finished package. So I'm just going to say this is my company name. And that's mostly what I'm going to do for now. We can also go to the HoloLens section under platforms, and under packaging we can also prepare this for deployment by creating a new signing certificate. So we can generate new, and I'm just going to keep none as an example, but you can set a password here for your certificate. I'm just going to pick none. And this would actually allow me to build and deploy to the HoloLens. But the beautiful part about Unreal is we don't have to build and deploy every time we want to see if something's working out. We can get a general idea via the VR preview, which we have to explicitly enable via holographic remoting. So on the HoloLens device itself, there is an app to allow holographic remoting. And checking this box will require another restart. So I will check the box and click restart. I've restarted Unreal and started the holographic remoting player app on the HoloLens. This is not the same as Remote Assist. Remote Assist is an application that allows other people to see what you're seeing and draw in your physical space and offer you other clues to help assist you with the task at hand. Holographic remoting player is something that allows you to essentially stream a scene to the HoloLens for preview purposes. So the first thing I'll need to do is write down the local IP of my HoloLens on my Wi-Fi, and I can click on connect. So at this point, I'm connected to the HoloLens device. So if I were to click on VR Preview, I would be able to run that on the HoloLens device. Now, what's even nicer is being able to work without the VR preview. So the first thing we really need to do is add a player start into this scene, and I'm going to make sure that's at 0, 0, 0. And let's see what happens if I just play in the editor. We see that the toolkit that we just installed includes these simulated hands. I can hold the shift key to move my left hand around. I can hold the alt key to move my right hand around. And if I zoom in and out, it will move the hand in and out of the screen. And if I click, it'll grab with the hand. It's very useful. I highly recommend trying to prototype as much as possible in the editor before you put on the device. So let's add something, anything, a sphere. And the sphere looks pitch black because we have no lighting. So let's center it to 0, 0, 0 just to see what will happen. And let's give it a material. So the toolkit itself comes with some simple materials. So we have grays and yellows and magenta just out of the box. I'm going to look at the simple lit green, because it's something other than blue like the hands. And I'm going to move it maybe, well, let's actually hit play and see what happens first. If I move back, by the way, I can move around with the WASD keys like I'm playing a first-person game. And you can see that this ball is rather large. So it's much larger than my hands. And something you need to consider is the sense of scale in this holographic world. So the units in Unreal are centimeters. So you're working on a much smaller scale for the mixed reality than you might typically work with in, say, a video game or some television or cinema project. So I'm going to scale this sphere to, I'll just scale it here maybe to about 0.2 of its current size. And I'll also move it around a little bit. I'll move it so that it's a little bit in front of our face. So if I were to save and hit play, we have this ball that's a little bit in front of our head, but maybe it needs to be a little further. So I'm going to, and apologies, I'm using a trackpad here, going to move it out a little bit more. So you can see that this is about 80 centimeters beyond the origin of the scene, which is going to be our head. So at this point we have a ball in front of us. Let's add some interactivity to our scene. It's pretty simple to do with the UX toolkit. We have this generic manipulator component, which allows us to define different manipulations with either one or two hands. And you can see that we can either translate, rotate, or scale objects. It applies some smoothing. We also have a near and far interaction mode. So what that means is we can actually go and physically touch something as if it were there, or we can essentially shoot a ray from our fingertip and interact with objects that way. And this makes it very simple, but there is still one more step that we have to do. First, we'll want to make sure that this object is set to be movable, otherwise that manipulator will not function as intended. And next we'll need some hand interaction actors. So if we go into our mixed reality pawn, we have a couple of options. We can either spawn them here, say via the begin play, so we can say spawn actor from class and select the hand interaction actor, or we can add a child actor to the pawn itself. So let's add a child actor, and we will call this right hand interaction, and this will be the hand interaction. And under UXT hand interaction, I will pick right hand. And I will duplicate this and have a left hand interaction. for the left hand. So I will compile this and save. And now if I run it in the editor, you can see that I'm able to drag this sphere around. I've added a cube as another frame of reference, so let's try this in VR preview mode. And you can see the cube and the sphere in front of me. And if I reach out with my hand, I'm actually moving the sphere. So this is not my head moving around, this is my hand moving the sphere. I can reach in with both hands and size the sphere. I can also move from a distance. If you look carefully, you can see a little beam coming from my finger, so this lets me manipulate objects at a distance, and I can actually also use both hands at a distance to freely rotate and scale the object. So you can see this generic manipulator is extremely powerful and handy, and it feels very natural. The next step might be to visualize the actual hands, and there are a couple of ways to do this. The easiest would be to essentially connect the dots between the joint positions that are predicted by the HoloLens. Another way might be to use a mesh, which is nice because then you can do something that's related to the context of your application. So for example, you can use construction gloves or even dinosaur hands. In this case, we're going to use the mesh from the UX Toolkit, which is nice because it gives us exactly what we need. It gives us a good reference point for a hand that we can manipulate. And we can see it has a bunch of bones defined. The majority of them, however, don't deform the mesh. If we really want to focus on the joints that we want to apply to this mesh, we only need to show weighted bones. So these are all the bones that actually affect the mesh. So on every frame, what we'll want to do is target these specific bones, and we can use an instance of this hand mesh to give us an idea of where our hands are. And this is helpful not just for VR preview mode, but it's also helpful when you're using an application because it might be hard to tell how far away your hand is versus the actual hologram. So what I've done is pulled out all those joints into an array as UXT hand joint, and I'll also need the bone names to be able to update them in a mesh, so I've created a function that just translates all those enum values into bone names. So we can see that the names are very similar, it's just they have a space in between things like index proximal, and it's going to replace those spaces with nothing. So it's going to remove those spaces, and that will match the bone names in this particular mesh. Next, we need a mesh to actually work with. So I'm going to add a new posable mesh. So this is a subset of skeletal mesh that you can just pose programmatically without any animation. So I'm going to call this right hand. And as the mesh itself, I'm going to use this input simulation hands, and I'll just leave it on the default material, but of course you can change it to any material that you would like. Let's add a handler for the tick event, and we'll want to get the hand joint state. This is going to be the actual transform as if it were a skeletal transform for the specific joint that we're looking for. So you can see we can define a hand, and we can define a joint, which is an enum of UXT hand joint. Now we have this array here, so we're just going to loop through this specific array of joints that we care about. And I apologize that Blueprint is a little annoying to move around with, but bear with me, please. So let's do a for each loop. So for each of these joints, we are going to get that hand joint state. So we have our array element here, joint. Convert these values into some kind of transform. So we have our position, and we have our orientation, and we'll leave scale as 111. Okay, we will need to set the scale later, but not at this time. Let's also multiply this result by the actual transform of the mesh. So let's get the world transform. And this will essentially translate this into world space. So let's plug this into here. Now let's use this to actually deform the mesh. I'm just going to get another reference here, and I'm going to set bone transform by name. Going to make sure that that transform is there. Make sure it's in world space. Connect this guy over here, and of course we can pull this name from that array that we had defined earlier. So we have this array of names that I'm going to simply get the index of based on the index of our loop. So let's do that, and let's see what happens. In VR preview mode, we're able to see our fully articulated hand matching the hand position that we are doing in the real world. Now, since it's VR preview mode, the thing to keep in mind is that this isn't actually rendering on the Hololens. This is rendering on the computer and streaming to the Hololens. Likewise, the head rotation and hand predictions are all being streamed back to the computer. So the actual performance will vary when you deploy to the device as a standalone package. So that's something to keep in mind, but otherwise it gives you a great idea of the user experience. One thing to note is, since we're moving the hand around via bones, the actual point in the world may be different than the point considered by Unreal for culling. So we want to make sure that the bounds are large enough to always intersect with the camera. So if we go into rendering, we can expand the category until we find bounds scale. And we can just make this a large value. I chose 1024, but you can use any large value that seems to consistently work. The next thing we'll want to do is tackle the left hand, which is a little bit different. This input simulation hand mesh is a right hand. So we'll want to actually mirror this hand along the y-axis to make it look like a left hand. Let's begin by duplicating the right hand to create our left hand. And let's mirror along the y-axis by setting the scale to -1. This is the first half of the equation. We'll also need to reverse the transforms for each joint. To keep it simple, I'll copy and paste the work for the right hand and adjust it to work with the left hand. Let's run this second sequence pin down here and change the get hand joint state to the left hand. Likewise, we'll want to replace these references to the right hand with references to the left hand. So that'll multiply the joint by the left hand's world transform, and we want to set bone transforms on the left hand. The other changes to make are to mirror the joint along the y-axis. Otherwise it'll look like the hand is imploding on itself. The last change to make is to the bone space. Because we had a nice uniform scale on the right hand, we could honestly either use world space or component space, but for the left hand, we should definitely use the component space in this setup. Let's give it a whirl and see what happens. You can see that I have both hands tracked and articulated pretty accurately, and now it will be much clearer when I start to interact with this object. And you can see that it's fairly intuitive, and it responds very naturally to my hand motions. So I can translate this cube and rotate it, scale it. The manipulator component can be adjusted in terms of its behavior, whether you want to constrain it on a specific types of transformations, or whether you want to be able to rotate it with one hand or both hands. You can also grab an object with each hand. So I can grab this cube with my left and grab the sphere with my right. Feels very natural. Any shakiness might be a artifact of me wearing this on my head, but when you actually wear this and experience it, it feels very intuitive. The last thing to keep in mind for this getHandJoinState method is it will return a Boolean value representing whether it was able to retrieve those hand joints or not. And if this value is not true, then we are able to hide the appropriate hand so it's not visible in the game. Otherwise, when you move your hands out of view of the Hololens, you may have disembodied hands floating in space. I'd like to touch on the materials a little bit. If you look at the shading model, all the materials that you make for the Hololens should preferably be in the unlit model, which means they won't be able to take advantage of Unreal's nice lighting engine, but it means it will run much more efficiently on the Hololens because it is indeed fill rate limited. And here's an example of a simple shader that just looks up into a cube map. So we already have the reflection vector available to us, and I'm just looking up into one of the engine's default cube maps. So let's apply that to our hands and see how it looks. Now my hands appear to be made out of chrome or some shiny metal. And it's very easy to customize the look of the UX Tools hands with materials. You can also use any other mesh as long as it has similar bones. So again, you can make the hands look like construction gloves or dinosaur hands or whatever is appropriate for your simulation and your experience. But I think we covered enough ground today. Thank you so much, and I hope you have a great day. Bye-bye.